right, good afternoon, everyone. I hope everyone's having a good day today. So today we're talking all about recursive relationships. So, because of how it can be kind of difficult to model these inside of SQL, I'm not going to ask you any questions on the exam in terms of, the specific queries for Chapter 6. However, I will certainly guarantee you'll have questions for Chapters 3 through 5 on the queries. I might ask one or two questions about what is a recursive relationship on the exam, but I'm probably not going to ask you to actually do one. And normally, in a regular semester, I'd have you draw one out on the test, but we're not doing tests in paper right now, and it's not really feasible for me to, have you draw one on, a test you're taking online. So I'm just going to assume that everyone knows how to do an entity with a recursive relationship. But that's all we're talking about today. It's just, what does this recursive relationship mean? Well, at the most basic level, it means that the entity has a relationship with itself. So right off the bat here, we could have person. So let me make this a little bit larger. So if we just had a person entity, why might a person have a relationship with another person? The primary key, SSN, then do FName, and then LName. So again, I'm going to give 5 points of participation today. So if you participate, you get 5 points on the upcoming exam too. So someone tell me, why might one person have a relationship with another person? So if there's a group situation, so they could be a member of a group. So let's take a look at what that would look like. So I'm not going to be able to get this exact because, well, but basically, I'm going to try to get this good. All right, can we all just pretend that goes to itself? Is that cool with everyone? Like I said, I apologize, it's just the best we can have. So basically, we'd have person is in a group, and a group is comprised of people. So person can be in, let's just say, 0 to many groups. And of course, the group can be comprised of 0 to many people. Actually, it probably couldn't be comprised of 0 people, because what do we have if we have a group of 0 people? We don't have a group, do we? So we'd probably actually have a minimum of 2 for it to be a group. So we'd probably just make this N symbol down here. Probably just make this 1 or more. And we would actually define with a text box here, we would put 2 up here. And of course, the reason for that is because the minimum amount of people you'd expect to have inside a group would be 2. If you have one person, that's an individual. That's not a group. So certainly this is a logical approach, but a person doesn't have to belong to a group. So we're actually going to label this relationship as well, because you could look at this and you wouldn't know what this was. So it's very important that we label all of these. I'm just going to call this group. Let's call it membership. So this is our group membership relationship. All right, and that was Justin, right? All right, great job, Justin. I think I got something in chat as well. Okay, family member or spouse. That's a great thing, Ethan. So let's take a look at what that would look like. So if we were to do a relationship, again, we're just going to pretend these two touch. Of course, we would expect for this to go somewhere like right here, and this to go somewhere up here. But unfortunately, it's not really feasible. You trying to say something? All right. So yeah, so basically, we would expect if we're talking about a marital relationship, we're just going to call it a 1-to-1 for everything. One person is married to one person, and one person can be married to one person. But does everyone have to be married? Can a person be not married? They certainly can. I mean, you don't have to be married. So, we're actually going to use 0 or 1, because you don't have to be married, but if you are married, you can't be married to more than one person at a time. Now, I know we could talk about some cultures where you probably could. We're going to keep it nice and simple and just go with this is a 0 or 1. So we just label this marriage. Spelled that right. Call it married. I know I spelled that right. So certainly, that's another example of a recursive relationship. Now, who can give me another example where a person has a relationship with a person? In fact, let's go ahead and, so we have friend. So certainly, if we were to model the friend relationship, we'd do the same thing. How many friends does a person have to have? Can a person have 0 friends? Yeah. Can a person have 1,000,000 friends? Probably wouldn't be very close with all 1,000,000, but you can. So it's going to be a 0 to many. And then, of course, any given person can have 0 to many friends as well. So it's going to be another relationship just like the group membership where they're going to have, the, only it's not going to be exactly like it because both symbols are going to be 0 to many. So certainly that's what we want to keep in mind is that different people can have different amounts of friends. There's no max or minimum amount of friends someone can have. Can you have a negative amount of friends? It depends on how if you define an enemy as a negative friend. I don't know if you would or wouldn't. So certainly let's keep that in mind. And then Leslie says employee and coworker. I think that's another good one as well. So let me just do a new entity for that. I'm going to call this employee. So if we have our employee entity, we'd probably have some primary key, call it empno for employee number. So you get first name, last name. And of course, then we'd have a relationship. Again, if I can kind of model this halfway decently, I'll be happy. So, employee is going to have a boss, and a boss is going to have one-to-many employees. It's just kind of the way it goes. If you're a boss, can you have 0 employees? Well, who would you be the boss of? Well, it'd still be an employee because you're inside the employee table. So I would probably set the minimum amount that a boss has to be 1. I think that makes the most sense. Certainly in case of self-employment, you'd still be an employee. So let's go ahead and just set this begin symbol down here to 1 or more. And then the end symbol is recognizing that, you're probably going to have one and only one boss. So if you're the employee and you have a boss, in this case, we're going to assume the business rule is you only have one boss and that you do have a boss. That's not always going to be the case. There could certainly be a case where maybe you work for different departments. Maybe there's a situation where the department has, a supervisor who supervises and a boss who manages. Certainly could be the case. We're just going to keep it nice and simple and just assume a good 1-to-1. So who's got another one? How about instead of just having a single entity, what if we had 2 entities? Who can think of 2 entities that have a recursive relationship between them? So if we had entity A and entity B, and let's just say there was a recursive relationship involved in these 2. Any ideas for that?
Butchers and packaging.
All right, let's take a look at butcher. And you said packaging? All right, what would you say the primary key for butcher would be? Butcher ID. And then you want a first name, last name? What? No, I mean, is that what you want to have about the butcher? Is the first name and last name? Or do you want to have other information about him?
It's just mom and pop shop.
So we'll just get first name, last name. And then what do we want to know about packaging? Should we get package ID? And what else? type of meat. Is that what we're doing here? Type of meat? Company? Is it just one company? We'll probably just not include that as an attribute if it's all for one company. If we were doing a case where we had several companies under us, we would probably want to have that information. But because we're dealing with a, like I said, a mom and pop shop, we don't have to have that specifically. So you're talking about, slicing up meat and selling it, right?
Yeah, like a butcher will take in the cattle from the farm, cut it up, and then ship it out to the.
So let's just get meat type and weight. And what makes this a recursive relationship? So butcher has a relationship with packaging, and packaging has a separate relationship with butcher. Is that what you're saying? So we would actually have two relationships in that case. And what would the first relationship be? So if we were going to just define the relationship, could we call this slices? Well, the butcher does, so we call this first relationship slices. So they slice the stuff, the meat. And then what would this other relationship be? Any ideas for what that could be? Well, now, profits wouldn't be represented in this.
Packaging company buying meat.
So that'd be in another entity. That wouldn't necessarily be a one-to-many. Certainly wouldn't necessarily be encompassed with the recursive relationship between two different entities. Any other ideas? So Ethan asked if it would be an orders. Yeah, you'd have another order entity, possibly, order transaction, lots of different other entities. But as of right now, we can't model a financial relationship because it wouldn't make sense for us to put any financial variables in either our butcher or our package ID. So just kind of keep that in mind. We can also have a meat table. Maybe the meat has a certain price per pound or price per ounce or whatever. There's lots of different approaches we could take with this, but as is, we can't discuss anything financial. So let's take a quick look at one of the book examples. I think the book does a pretty good job with this example, and this is going to be a recursive relationship where a club has many members. So we have a club entity, and of course we have a member entity as well, and then we also have a person. So we're wanting to get information about the club's members. So we have two different positions here. Those are going to be recursive entities, where we have a person is going to be president of, in this case, probably 0 to many clubs, but the club has one and only one person who's the president. So I don't like that they don't define the modality here as 0, because any given person does not have to be a president or treasurer of a club. If you look at this, they do. So certainly keep that in mind. That's one mistake. Now, who can tell me a way we could simplify this recursive relationship a little bit? So if I don't want to have president and treasurer as separate recursive relationships, what could I do? That's exactly right. So what Jarek just said was, we're going to go ahead and just kind of condense those into one single recursive relationship, call it maybe officer, call it maybe role, call it maybe position, something to that effect where we can represent that as having, the information stored for what specific role we're talking. So certainly something we could do. Like I said, this is just one example. Go through some of these others. You kind of see they made some slight changes here. basically they're saying that this is now going to be a one-to-one, where we only have one person being the treasurer for one club, as opposed to them being the treasurer for many clubs. So, you know, who's in a club in here? Anyone in any clubs? What club you in, Jarrett? Okay, very cool. So within inside of that club, you said you're some sort of leader, right? Could you be a leader of another club as well? Certainly could. So would this be a logical data model where you can only be the president of one club or you can only be the treasurer of one club? Probably doesn't make a whole lot of sense. So how can we fix this? Anyone have any ideas for how we could fix these relationships? So let's talk about what the issue with this relationship is. It's not logical to say that there's some inherent rule excluding someone from being involved in more than one club in terms of having an officer position. You know, because if you think about it, each club has independent rules. Certainly one single club could have the ability to say, if you're an officer of another club, we don't want you to take an officer role in our club. It's certainly something one could do. But can every club do that? No, because each club is governed independently. So to have a one-to-one relationship, in my opinion, doesn't make a whole lot of sense. So all we have to do is just make that a one-to-many on both of those, and then we'll be in a good spot. Because certainly, if we have a club, they're only going to have one person as president. But, of course, we could also address this by having the, you know, if we want to get rid of the treasurer and the president, why not just add another attribute to membership and just say position? And that could be standard member. It could be president, treasurer. More logical. So as is, unfortunately, it's just not very logical. Just got a notification I'm getting a bad network quality in here. Let me know in the chat if you guys are having any trouble with the stream. I do apologize for that. I think campus network has been a little bit shaky these past couple days. So I do apologize if there's any issues with that, but certainly let me know. All right, let's see what else we have here. So we're taking this a little bit further here. Who wants to explain this entity right here? So this ERD, rather. So anyone want to take a crack at explaining this? So it looks like we actually have some redundant information on here. You see we have treasurer represented not just once, but twice. We have president represented not just once, but twice. Do we need that? We hardly ever need redundancy. Certainly, in this case, this is not a logical data model. So if we look down here, we see another example of a recursive relationship where we have the researcher and the team lead. So we have a team which is comprised of researchers, and then we have, you know, certainly we have the collaboration there, where it's describing as an associative entity, rather an associative entity. This is what we're doing. So we're getting a researcher and we're getting the team, placing those into an associative entity there to address the many-to-many relationship. But then we have a team lead serving as a one-to-many recursive relationship here, where a researcher is the team lead for one and only one team. And according to this, we see that team lead has one and only one researcher serving as team lead. So does that make sense? Can a team have more than one team lead? Well, by definition, lead is singular. Team leader, that's singular. So I would say probably not. You know, if it said team leaders or team co-leaders, then we could. But it doesn't, so that part is logical. So certainly, this makes a lot of sense so far. So Any questions about anything as we're going? Like I said, today's going to be a lot more relaxed than maybe some of the other days where we're doing a lot of stuff in SQL. Because you look at some of these scripts and stuff you'd have to do, it just gets pretty complicated, and I can't really ask a whole lot of questions on the exam based upon this anyway. So we're just going to talk about it from a more hypothetical standpoint. So here's another example here where we have an employee who, in this case, has a mentor. So employee has one mentor, but can mentor one-to-many employees. So we certainly have some flexibility there in how this relationship is represented. So let's keep going a little bit. So we're going to skip this example. Here's a good example right here. So we have the Gourmet Food Club selects food products via home parties. Probably some sort of MLM, it sounds like so far. Amy runs one of these clubs and wants to be able to track who has come to her parties and who has hosted a party for her. She collects all the contact information about her customers and tracks the time and date of the parties she has given. A customer may attend many parties, and customers have many, or parties rather, have many attendees, and a customer can also host parties. But each party is hosted by one and only one person. So we can see here we have several different recursive relationships. First, we have spouse. If a client is married to another client. Now, I don't like how this is represented. What's the problem with this? Why might I not like how this is represented, this relationship for spouse? Probably not party, because party is talking about like a party being married to another party. It wouldn't make a whole lot of sense. So a client could marry another client, but what's the problem with how this is represented? Any ideas? So the problem is there's no, there's no optional instance of this relationship. It's one-to-one. Each client has one and only one spouse, and the reverse is true as well. But not everyone's married, and certainly if you have a client database, what are the chances you're going to have, if someone is married, that they're going to have their spouse included in the same database? It's pretty unlikely. So I think it makes a lot more sense for both of those sides of that relationship to be minimum, of 0. So right now they have a minimum of 1. It's implied if there's nothing there, according to this nomenclature, we assume it's 1 and only 1. So that really doesn't make a whole lot of sense to me. So certainly if I ask a test question, what is the problem with this, and I have, a one-to-one for both sides of it, you're going to say, well, wait a second, that's not logical. You can't have, you could certainly have people who aren't married. You could certainly have people who, that doesn't apply to. So we're just going to keep that in mind. Then we have a unique one here where we're adding on the child relationship. So in this case, person has one-to-many child, and child has one and only one person. Now, what's the problem with that? Why would we not say that a person has one and only one child? So, this is really the parent relationship we're talking about. So we're saying, in this case, let's say father is the only parent associated with one child. Is that logical? I mean, I'm not aware of any cases where a person doesn't have a biological mom and a biological dad. So, to represent this as a one-to-one, I don't think is very logical. Because, certainly it's logical that a person can have more than one child, but it's not logical that a child will have one and only one parent in terms of that. So we'd want to avoid that sort of thing and just make sure that we represent that in a different way. So any questions so far? All right. So that's really about all I had today. I just want to go through some examples of various entity relationship diagrams that we might see on various assignments in the future. Like I said, I'm not going to really ask you any SQL queries for Chapter 6, but certainly Chapter 3 through 5. Those will definitely be basic queries on the exam. You shouldn't have any issues with time. There will be 10 questions on the exam. I'd say a little over half of those are probably you writing queries. 1 or 2 of those are you telling why a query doesn't give something, just telling how to fix it, and then maybe 1 or 2 other knowledge questions on there. So it's pretty much what it is. Any questions? All right, well, I hope everyone has a great day. I will see you all Friday for the review.